you get the same answer. Okay, let me see. Okay, so the answer is 3.19 diopter. Okay, so if you get if you don't get this one, you can let me know and we can do it together. Okay, so as you can see here, for patients who have -10, okay, you can see that the accommodations required will be even less compared with the patients who have -5. In -5, you have about 3.5, and this is about 3.2. So you can accommodate 0.3 diopter less than -5. So for those who have high myopia, I think usually the accommodations would be less. So that's why for those who have high myo, so they may develop the presbyopia later compared with the other group of patients because they need less accommodations for the same working distance. So far, I think you use the formula to do the calculation, and sometimes you may find it difficult to memorize it. Okay, and there's another method that you can use to do the calculation, which is called the step-along method. So this method, I'm not too sure if you have learned this in optics lectures. If not, I think you're going to learn this one in the ophthalmic and dispensing. Okay, later on. The method is very useful, particularly if you are dealing with a very complex optical system in which you may have a multiple optical surface. One of the key elements in this method is that the image formed by one surface. For example, if you're dealing with a multiple surface optical system, the image formed by one surface will function as the objects for the next one. So even though, for example, if you have 7, 5, whatever number you have, so the calculation is still the same. So you can deal with this more easily. So it's work best if you have multiple optical surface here. If I use the same example, I think this we use the same diagram. So in this case, we also have two optical surface here. So one is the optical lens, the spectacle lens. The other one, another optical surface is the eye. And you can use this method, the step-along method, for the calculation. Okay. Let me show you with one example here. Okay. So the one information given is that the object distance is at 25 centimeter in front of the lens. Okay, the first optical surface. Okay, so this is the LC. LC is equal to minus 25 centimeter. Of course, the SI unit is in meter, so that's, I think you should also put down as minus 0.25. For this step-along method, you have to create two columns. So one column is about the distance. The other column is about the diopter. With the LC, then you can take the reciprocal. From the object distance, then you can get the object's vergence. Okay, the object's vergence is equal to -4, just by taking the reciprocal of the object distance. Okay, so it's easy. And then with the lens power, remember, the second step is to do this one, the LC pi equal to LC plus F. Okay, so -4 plus -10 will be equal to -14. Okay, LC plus FSP equal to LC pi. So now you can get the image vergence. From the image vergence, you can go back to the image distance by taking a reciprocal. Okay, so this is LC plus FSP equal to LC pi. Taking the reciprocal, then you can get the LC pi. LC pi is equal to minus 7.14 centimeter in front of the lens, spectacle lens. We'll repeat the same on this side by considering the D in front of the eye. Okay, so here you can see that with this equation. Remember, we talked about this. The LC, if you look at this one, so the LC pi minus D equal to L, or L plus D equal to LC pi. So that's why you can get the L from the LC pi. Taking the reciprocal back, then you can get the L. Okay, so this is for the object's vergence at the optical surface, at the principal surface of the eye. For the FSP, I think we can do exactly the same. Okay? But if you want to use the effectivity formula, it's okay. Okay, if either one is fine. You can use effectivity formula or you can use this one. The second part is about the FSP. FSP, if you take the reciprocal, it becomes the FSP, the focal length. Okay. But you may have to refer to the other diagram here. Okay, from the FSP you can get a K. Remember the diagram that I show you with the difference between the spectacle and also the ocular refraction. Okay, with that diagram, I think you can do this interconvention, and then from the K, the far-point distance, you can get the K, the ocular refraction. Okay, so for this part, you can also do the same. Okay, you can either memorize the equation, the effectivity formula, or you can use this calculation. Okay. Now with K and L, of course, then you can do the calculation, and the answer for this question is 3.19. So the answer is exactly the same as you use the formula. Okay. Okay. So so you can either choose to use this step along method or using the equation. I mean, either one is okay. If the patient is wear contact, I think the answer is the same. So 3.85. Okay, regardless of whether you are myope, hyperope, okay, it's always be the same because the distance from the eye is the same. When you're using spectacle accommodation, if you have -10, it's about 3.2, a little bit less than 3.2 diopter. With contact, so your accommodations required is about 3.85, okay, same as ametrope. So that's why for the accommodative ratio refer to the ratio of accommodations to that required by ametrope. Okay, so you can use in here will be 3.19 divided by 3.85, so it's about 0.83. So meaning that for patients who have -10 diopter myopia, they can accommodate maybe about 17% less as compared to an ametrope. So for myopic patient, this value is usually, accommodative unit is usually less than 1. Okay. That means they accommodate less with respect to ametrope. If you do the same for the patients who have +10, I mean, it is, although it's quite rare to have patients with 10 diopter of hyperopia, but sometimes you may also have patients who have a very high amounts of hyperopia. If you do the calculation, so you can see that the amounts of accommodation needed is even higher. Okay, so here you need about 4.7 instead of 4.25 for the +5. If you use the step along method, I think it's the same. Okay, you can see that. Okay, I create 2 columns here. Okay, one is the distance is the same, so that's why you get the same object's vergence. Okay, and then the lens, the FSP, instead of -10, this is +10. Okay, because this is a hyperopic patient, and that's why the LC pi instead of negative is positive. So that meaning that the image is not forming on the left-hand side, but it's on the other side. Okay, for hyperopic patients, because the image has to be directed to the far point of the patient. Okay, and so this LC pi, you can convert it back to the distance. So it's about 16.67 centimeter behind the lens. Okay, and because we have 1 centimeter in between here, is 1 centimeter, so that's why the L, the adjusted L, is about 15.67 centimeter behind the optical lens. From there, you can calculate the new object's vergence, which is 6.38 diopter. We repeat the same for this effectivity formula, so that you can work out the amounts of K from FSP +10. It will become 10 centimeter, and then D is equal to 0 and equal to 1 centimeter, and that's why the K is equal to 9 centimeter. Okay. From the optical surface from the principal surface, and then the K is about 11.1 diopter. Remember, in hyperopic patient, the magnitude of K is always higher than the FSP. Right? In myopic patient is the opposite. When you use contact lens, you use smaller power. Remember, when you use spectacle, you use a higher power. But the opposite apply in hyperopic patient. Now you got K and L, and therefore you can see that the amounts of accommodations requires about 4.7 diopter. So the same as you use the formula. So with spectacle, you have to accommodate more. When you use contact, same as the other condition. So it's about 3.85. So for the accommodation unit,